go to page 72 in your journal and get the definitions for quadratic inequality in 2 variables and 1 variable. Then let's take a look at the core concepts. Today we're going to be graphing quadratic inequalities, and when we're graphing them in 2 variables, we have to follow these specific steps. So step 1 is going to be to graph the parabola with the equation equals. So we're going to pretend that there's an equal sign there with the y, and we're just going to plug in my ax squared plus bx plus c into my y equals. And then if there is a less than or greater than, we make a dashed line. If there is an equal to underneath, we make a solid line. Next, we'll test a point inside the parabola to determine whether the point is a solution, and that's going to be the side that we shade. So if the statement is true, we shade the region with the point, and if the statement is false, we shade the region without the point. Now let's take a look at example 1. For example 1, I'm going to go into my graphing calculator, and I would enter y equals negative x squared minus 2x minus 1 and take a look at the table. We know how to do this in our calculator, and when we go to y equals and plug this in, these are the 3 points that I will get for my graph. And I'm going to plot those, negative 2, 0, or negative 1, 0, and 0, negative 1. And then I see the sign is a less than, so I'm going to make this a dotted graph. To figure out where we shade, we're going to test the point. I always like to test the point 0, 0, unless the graph crosses through 0, 0, but this one does not. So we're going to plug in 0 less than negative 0 squared minus 2 times 0 minus 1. This statement gets us 0 is less than negative 1. Is that true or false? That's going to be a false statement, so we shade the side that does not have 0, 0, which would be underneath my parabola. So looking at example 3, we're going to graph a system of quadratic inequalities. What that means is we're going to graph each of these separately. So we'll graph y is less than negative x squared plus 3. And then we'll graph y is greater than x squared plus 2x minus 3. And we're going to figure out where the shadings overlap, and that's going to be our solution. So taking a look at the first one, I'm going to graph this in my calculator in y equals and make an xy table. My table for this graph here is going to be negative 1, 0, 1 and 2, 3, 2. Because my vertex is at 0, 3, then I have negative 1, 2, and 1, 2. Will this line be dotted or solid? Look at this. Yeah, it should be dotted. So I'm going to draw a dotted line there. And let's test the point 0, 0. If I plug in 0, 0 for this equation here, I get 0 is less than 0 plus 3, which is 3. This is true. So I'm going to shade below, because 0, 0 is in there, below my graph. Now let's check out the next graph. If I make an xy table and plug that into my y equals, I'm going to get these 3 points for my vertex and my other 2 points. And the reason I know this so quickly is because I'm also looking at Desmos. So if you go to Desmos, you can type in the 2 equations on your left, and this is what my graphs should look like, except dotted, solid, and shading. The graphing calculator can't do that, so we're better than the graphing calculator. So when we go back to here and we want to graph this, I'm going to plot negative 1, negative 4, and it's inside the red area, then negative 2, negative 3, and 0, negative 3. Will this line be dotted or solid? Take a look. Yeah, this one should be solid, so I'm going to make a solid U shape going up. And if I test the point 0, 0, so plug in 0 for all my variables, I can see that it's going to say 0 is greater than or equal to -3, and that's also a true statement. So I shade everywhere above this, where 0, 0 is, above the blue. And my intersection, I'm going to shade in black, so you're going to see here, my solution is this section in between the two functions. Make sure you bring your notes to class, and we're going to practice this tomorrow.